In this video, we're going to start getting into the real power of Excel, and that's how you do calculations within cells in the program. So this is a great video for anyone who doesn't know how to use formulas in Excel or how to do calculations in Excel. And as with other videos, the recommendation would be to open up the associated spreadsheet for this video. I've made you a spreadsheet that will actually, I think, help illustrate how this is done. Follow along in that spreadsheet. You can pause the video as you need to, and make sure you're trying all these exercises as we go through this. So go ahead and open up the Intro to Calculations spreadsheet that goes with this activity. Now, this spreadsheet is actually linked to the example that I gave in the video on population growth rates. So we're going to calculate absolute growth rates, and we're going to calculate relative growth rates here. So for anyone who has not worked with Excel before, and specifically with the functions you can put in cells, let me give you a quick overview of how this works. I'm going to zoom in. Hopefully you have the spreadsheet open now. And I'm just going to put a couple numbers in two cells. So I've put a 2 in E4 and a 2 in F4. Column F, row 4. So here's the neat thing. So if you want to say add these two numbers, the way you start that dialog in Excel is by saying equal. Now if I say equal, I can actually click on the first one, and you can see it put in E4. I add a plus, and I click in F4, and I hit a return. Now it calculates for me. Now the neat thing about this is that I can start changing the numbers, 5, 10, and so on, and they will update. That's a really, really handy feature when you start getting very complicated numbers. Whoops, I added a plus in there. And actually, that's an important point because the type of data will affect whether or not your calculation works. So if I convert that back to a number, it works. Okay, so that's how the basic process works. Now, this gets really complicated. So for today, we're just going to do some basic things. The way I have this set up is you have two tabs, absolute growth rate and relative growth rate. So in both tabs, I've given you a lot of information and actually a model for how to do this. What I'm going to do now is recreate what I've done with the existing columns and show you how to do it yourself. Okay, I have two starting values. Absolute growth rate, 20,000. This would be, I'm just going to write it up here, people per year, and a starting population. It's always good to keep your units on there so you remember what you're talking about. Okay, so these are both two values. You can see in C2 we have 20,000 and in C3 we have 1 million. All right, so let's make two columns. I'm going to make one for year, and I'm going to make one for population. Year, I'm just going to do 10 years to start with. Okay, so now let's look how we do this. So ideally, when you start building a spreadsheet like this, you want to be able to change things. So let's say you have a different starting population. Instead of 1 million, you want 10 million. Rather than having to type that in all over the place in a spreadsheet, we just want to put it in one place up here in C3. So here's a cool thing. I can say equal and then click on that cell, C3, and it puts in 1 million. Now if I change this number, it changes automatically. Nice. Super handy time-saving feature in Excel. All right, so we have now this cell, E6, reference to the other cell, C3. Now, when we want to do something, in this case, add 20,000 people, I'm going to say equal our starting number, which is E6, plus our absolute growth rate, which remember, it's not a percentage or anything, it's just a number, 20,000, and return. Okay, that's great. That worked really well. So for year 3, I want to take the cell E7 and add 20,000 people to it. Now there are two ways to do this. So let me show you the hard way and show you the easy way. Hard way, equal that cell plus the first cell we started with, C2. Okay, You imagine doing this 100 times. It gets old. Let me show you the easy way. I have a formula up here. You can look all the way up to the upper left. It says fx equals e6 plus c2. Now what's pretty cool about Excel is that you can fix a cell in place, and you do that by putting a dollar sign in front of it. So I put a dollar sign in front of a 2, and that means that no matter what row I'm in, because 2 refers to the row, I'm always only going to look at that row 2. I could do the same thing actually in front of the column, and if I was moving between columns, it would always refer to C rather than D, E, or F. Okay, so if I do that, I fix those two, and I do the calculation, I just simply copy it down, you can see it updates. And if you look at the actual formula, it holds that cell C2 fixed. Really, really nice. Very handy way to do your calculations. Just for one more example, let me just show you what happens if I pick my number up. I'm going to copy from E7, and I'm just going to move it over one column. I'm going to paste it in. So it went to 20,000. So why did it do that? And this is a good thing to understand about how Excel does this. You can see in the equation up here that the new equation says F6 plus our fixed value that's stuck in C2. F6 happens to be empty, but you could see if I put 15 in there, it would update. So what Excel does when you copy and paste a formula, if you don't tell it to hold it constant with these little dollar signs in front of the values, it will just update. If you move it one column to the right, it will move the equation one column to the right. If you move it one row below, it'll move the equation one row below. It's a very nice way to do one action, say multiply a row of numbers, and then go over to the next row of numbers, just copy that equation, plug it in, and it will automatically update. But it's not always what you want, which is why we have this little dollar sign to hold our values constant. Okay, so you can go ahead and play around with that. That gives you the absolute growth rate. That's pretty easy. So let's take a look now at the relative growth rate. So I'm going to switch over to that worksheet. Here you see I even have a graph pre-made for you. We have the same kind of basic idea. We have initial population of 1 million, a growth rate here as 2%. Now you can see up in the upper part of the spreadsheet it says that this is a percentage, so it knows that this value is 2%, and so we'll treat it as that, not as a 2 but as a 0.02. Now everything else on this spreadsheet is very similar. We're going to put in an equation. So the first one, we just simply reference our starting cell. Our second one looks a little more complicated. So I'm going to spell out the equation for you here. And what it says is that the starting value, in this case 1 million people, times 1 plus the growth rate, and then that is raised to the actual the time period. So if the growth rate is in per years, then the increment we're looking at is also in years. So if we go from year 1 to 2 with a 2% annual growth rate, then we're looking at 1 year as that exponent. So you go the initial value, 1 million people, times 1 plus a growth rate, which would be 1.02 in this case, raised to the time increment we're looking at, which is 1 year. If you were doing 10 years at a 2% growth rate, then that would become a 10. Here, it's just a 1. So what's in the cell? F6, which is your starting value, times 1 plus B $7, because that's our reference value for 2%. This little hat sign is the exponent. And what I did here is put a parenthesis and said E7 minus E6, 2 minus 1. Why do it that way? Why not just put in a 1? Because maybe I wanted to do something like this. Change it to year 10. It automatically updates without me having to go in, change the equation, or do anything else. Really handy, really nice way to have a flexible system for doing updates. Now, last point here. What's really great about this is that we actually just have an exponential calculator here. You can do it in your savings account if you want. It's the exact same equation. If you have $1,000 and you earn 5% per year, then in 100 years, you will have $125,000. Same thing with people. Start with 1,000 people, 5% growth rate, you'll have 125,000 people in that time period. So what's really neat is every time we adjust these values, you see the graph adjusts as well. If I want to change it to 50, the graph adjusts accordingly. So basically you built a little Excel model here where you can mess around with any kind of data, any kind of input data, any kind of percentage growth data, but because you've got the equation set up in the right way, it will go through and calculate your new results. So best way to learn this is to just get in here and really try to figure it out. You may have some questions. A lot of these you can look up online, but just keep in mind that there's a very specific logic to the way that Excel works. You start with the equal sign, and then you say what you want to do, clicking on the cells you want to include and using that dollar sign if you want to hold a row and or a column constant. All right, good luck.